So for this video, we're going to talk about a couple of theorems that go along with dividing polynomials. The first one is the remainder theorem. And so the remainder theorem says that if you divide a polynomial by x minus c, meaning that you're using synthetic division, okay, then the remainder is f of whatever was in the box, okay? So the idea here is I can actually, instead of having to plug in a value, I can actually go in and run synthetic division. And I don't know about you, but I'm a whole lot better at adding and multiplying than I am trying to run up powers. So the example that we're going to look at, I'm going to come back and cover factors in just a second. So they want us to use 3x cubed plus 4x squared minus 5x plus 3, and they want us to find f of negative 4. Okay, so what this is going to look like, okay, is now when we set up to do synthetic division with this, okay, we do not have x plus or minus a number. They just gave us a number. So we're going to plug that number straight in the box. So this is a little bit different than if they asked us to divide it, okay? This is just straight where you just plug it in. So process is still the same. I'm going to need all of my exponents shown and represented. So I've got x cubed, x squared, x, and my number. I'm going to skip my line and draw a line. And again, I'm going to drop that first one through, okay? So negative 4 times 3 is negative 12. We're going to add 4 plus negative 12 is negative 8. Negative 4 times negative 8 is positive 32. And then we're going to add negative 5 plus 32 is going to be 27. Negative 4 times 27, 108. So this is negative 108. 3 plus negative 108 is negative 105. This answer, which is in my remainder spot, that is my answer. Now, we can check, okay, what is actual f of negative 4? So we've got 3 negative 4 cubed plus 4 times negative 4 squared minus 5 times negative 4 plus 3. So negative 4 times negative 4 is positive 16. 16 times negative 4 is negative 64. Negative 64 times 3 is negative 192. Lovely. Negative 4 squared is 16. 16 times 4 is 64. Negative 5 times negative 4 is positive 20. And 3, I'm going to put all my positive stuff together. That's 64, 84, 87. That is negative 105. Now, I don't know about y'all, but I am a whole lot better at just doing drop and multiply, add, than I am with trying to run through all of these powers. Now, granted, a calculator could assist, but if I'm in a pinch, I can run that option, okay? So now, the other theorem that we are going to look at, okay, is called the factor theorem. Okay, so let me pull this back up. Okay, so the factor theorem is kind of what it sounds like. If I asked you to give me the factors of 18, you would tell me 1 and 18 and 2 and 9 and 3 and 6. And the reason that you're able to tell me that those are factors is because those are numbers that when you divide 18 by that number, there is nothing left over. Okay, there is no remainder. So the factor theorem works in two parts. One, if I find f of c is 0, so I'm running some division stuff, and I find a particular one that gives no remainder, then x plus or minus, so that x plus or minus version is a factor. Okay, period, point blank, it is. Now, if they tell us x minus c is a factor, then when I run it through synthetic division, I better not have a remainder left over. Now, let's take a look at what this is going to be presented as. So, it asks us to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0. Now, first off, we can't do that with any sort of factor by grouping or anything like that. It says, given that negative 1 is a 0, okay? If they're telling me it's a 0, then I also have that I can set up a factor for that. So let me show you what that looks like. Okay, so we've got 15x cubed plus 14x squared minus 3x minus 2. Now, I'm going to do two things here. One, we're going to talk about the zeros. And two, we're going to talk about the factors so that you understand how these set up, okay? Now, they're telling us that -1 is a 0. Now, factor for that. This would be the number that would be in the box. If I was doing that, what does that look like with the x? It goes with the opposite, okay? Now, if they're telling me this is a 0, then I should be able to put -1 in the box. And I should be able to run synthetic division with this, and I better get 0 in this last spot. So here we go. I'll drop my 15 through. -1 times 15 is -15. 14 plus -15 is -1. -1 times -1 is +1. -3 plus 1 is -2. -1 times -2 is +2. -2 plus 2 is 0. Okay, it worked. Now, the concept here is if you want me to find them all, I need to be able to work this down into something more familiar. Remember that all of our stuff drops by 1 exponent. So if this was x cubed, this is x squared, x, number, remainder. So what we now have is 15x minus x minus 2. But that's a quadratic. We got lots of options for how to solve a quadratic. So let's talk about how we could do this. One option is certainly to factor it. Again, we're still having this set equal to 0. So it's going to have to be a 1 with a 2 on the back. 15, I can do 1 and 15 or 3 and 5. 3 and 5 is going to be it because if I put 3 with the 2, I'll get 6 and 5 with 1. 5x, it's positive. Okay, now these are now my factors. So 3x plus 1, 5x minus 2. So if they're asking for factors, I've got them all. Okay, now to finish this, I would set 3x plus 1 equal to 0 and 5x minus 2 equal to 0. I'm going to subtract 1, divide by 3. I get -1/3. Okay, and over here I'm going to add 2, divide by 5. I get 2/5. Okay, so my zeros or my solutions will be -1, -1/3, and 2/5. If I needed to talk about my factors, I have those there.